Okay, so I'm going to start with this problem. So I'm going to read it. A large purse is full of coins. You count them by 13s, 23s, or 31s. There will be one left over. If you could count them by 73, there would be, if you count them by 73, there will be none left over. How many coins are in the purse? So I started out by writing the problem kind of in my own words. I said, how many coins are there in the purse if three numbers are within one, and 73 is divisible by the number? So the first thing that I thought of doing is finding the least common multiple between the three numbers. And one of the things that I noticed was these are three prime numbers, so that means you can multiply them all together to find the least common multiple. And then after I did that, I was going to try and see if that was the number of coins, if I just added one, if that will work. So you can see on right under question 3, I started doing that, and I realized that when I added 1 and then divided by 73, I got a decimal number, so it didn't work. And so I realized that, as you can see right here, I started to make a chart of all of these numbers, but then I was like, actually, it would be a lot easier if I plugged all of these numbers into an Excel sheet. So that is what I did. So on this column right here, where my pointer is in the A column, that is all of the numbers multiplied. So the first one is the LCM, and then I took that and multiplied it by 2. So 9,269 times 2 is 18,538. And I did that all the way up to the number 40. And then in this column is just this number plus 1, because that's what the problem says, is that the number plus 1 would be divisible by 73. And then in the D column, I divided all of these numbers by 73. And it wasn't until I got down to this row right here that I got a number that worked. So I checked it to make sure that it would work, and 342,953 does divide into 13, 23, and 31. It does work. So you can see the math that I did right here for it to work. And then when I added 1 to 342,953 and divided by 73, I got 4,698, which works. So the number of coins in the purse is 342,954. So as I stated earlier, kind of my answer to number 5 is that I started making a chart and realized pretty quickly that it would take a very long time to get to the number that I needed. So instead I decided it would be easiest to put it in an Excel sheet and let the spreadsheet do it for me. So that worked out pretty great. And so now I'm going to do the second problem, which I really liked this problem a lot. It was just, I liked it. A man's boyhood lasted for a sixth of his life. He played soccer for the next 12th of his life, and he married after a 7th more of his life. A daughter was born 5 years after his marriage, and the daughter lived half as many years as her father did. If the man died 4 years after his daughter, how old was the man when he died? So kind of restating the question in my own words, I said, how old was the man when he died, using the fractions that were given? And so for me, I'm a kind of a visual learner, and so it was important for me to kind of draw out the timeline in order to make sure that I didn't miss anything. So the first part of it is a man's boyhood lasted for a sixth of his life. So I drew out his boyhood and put 1/6. And then for the next 12th of his life, he played soccer. So I added 1/12. And then after a 7th more, he got married. So 1/7, and then he was married. And then 5 years later, his daughter was born. So, and this one is a little different. It's not a fraction. We actually have a number for this, which will be helpful. And then it states that his daughter lived half of his life. So I put this part right here, and that equals 1/2. And then after his daughter dies, he lives for 4 more years, and then he dies. And so for me, what was really important is, I guess kind of the game plan was using this information because we have the fractions. We can add all the fractions together. And then we also have years. So I added all the fractions together right here and got 25/28 plus 9 years equals his whole life. So if 25/28 is equal to the part that wasn't in years, then that means that 9 years has to equal 3/28 of his life. So if that's the case, then it's a simple proportion problem and you just solve for x. So I solved for x, and you can see my work here that I did that. And so x equals 84, so that means that he lived for 84 years. I didn't really vary very much from this method because I thought that I had a pretty good game plan going in, and I think that I just thought that this would probably be the best and quickest way for it to work.